Hi! Today, we will learn about addition and subtraction of radicals. Our objective is to add and or subtract radical expressions. Radicals can be added or subtracted if they are similar or like radicals. Similar or like radicals are radicals whose index and radicands are the same. Here are examples of similar radicals. First, we have square root of 5, 3 square root of 5, and negative 2 square root of 5. Another example of similar radicals, we have cube root of 2 over 5, cube root of 2, and 6x cube root of 2. So if you will try to observe, the given examples have the same index and radicands. Next, we have some examples of dissimilar radicals. First, we have square root of 5, 2 fifth root of 5, and fifth root of 5. So if you will try to observe, not all of them have the same index and radicand. Another example of dissimilar radicals are cube root of 3, cube root of 3x, and cube root of 2. They may have the same index, but they do not have the same radicands. So still, they are dissimilar radicals. Similar radical expressions can be added or subtracted the same way that monomials are added or subtracted. So remember that in adding monomials, say for example, we have 3x plus 2x. The sum is 5x. 8y minus 5y, the difference is 3y. So how we add or subtract monomials is the same way that we add or subtract similar radical expressions. Okay, let's have an example. Let's say we have 3 square root of 2 plus 2 square root of 2. The sum is 5 square root of 2. So if you will try to observe, we simply added the coefficients 3 and 2. That is why we got 5. And then copy square root of 2. Another example. 8 cube root of 5 minus 5 cube root of 5. 8 minus 5, we get 3. And then just copy cube root of 5. So the answer is 3 cube root of 5. So that's how we add or subtract similar radical expressions. Let's have more examples. Simplify 3 square root of 5 plus 6 square root of 5 minus 2 square root of 5. So we will perform the operations from left to right. So first we have 3 square root of 5 plus 6 square root of 5. These are similar radicals because we have the same indices and same radicands. First we will add 3 and 6. So 3 plus 6 is 9, and then just copy square root of 5. Bring down minus 2 square root of 5. Here we have 9 minus 2, 7, and then copy square root of 5. So for our final answer, we have 7 square root of 5. Okay, let's have another example. Simplify square root of 3 plus 2 square root of 7 minus 4 square root of 7 plus 5 square root of 3. So remember that we can only add or subtract similar radicals. So let us first identify which are similar radicals. Okay, so square root of 3 is similar with 5 square root of 3. And then 2 square root of 7 is similar with 4 square root of 7. So first, we will first add square root of 3 and 5 square root of 3. And then we have plus 2 square root of 7 minus 4 square root of 7. Remember that for the first term, square root of 3, it is understood that there is a coefficient 1 here. So if we add the first and second term, the sum will be 1 plus 5 is 6, square root of 3. And then, combining 2 square root of 7 and negative 4 square root of 7, that will give us negative 2 square root of 7. Now we have 6 square root of 3 minus 2 square root of 7. This will be our final answer. We can no longer combine these terms because they are not similar, since they do not have the same radicands. Another example, simplify 7 square root of 98 plus 5 square root of 32 minus 2 square root of 50. So if you will try to observe, the radicands can still be simplified or reduced. So that is the first thing that we have to do first. Let us first simplify square root of 98, square root of 32, and square root of 50. So for easier solution, let us get the prime factorization of each radicand using factor 3 method. For 98, so 98 is the same as 2 times 49. 49 is 7 times 7. So let us now circle the prime factors. Remember to look for a pair of prime factors. Write it once, and then the prime factor with no pair will be left inside the radical sign. And then for 32, we have 2 times 16, 2 times 8, 2 times 4, 2 times 2. First pair, write it once. Another pair, write it once. And then the other two has no pair, so we will leave it inside the radical sign. Simplifying this, we have 2 times 2, 4 square root of 2. This is 4 square root of 32. Next, let's have 50. So this is 2 times 25 and 5 times 5. So this is 5 square root of 2. So we will rewrite this 7 square root of 98 plus 5 square root of 32 minus 2 square root of 50. So we have 7 times the value, or in simplified form, square root of 98 is 7 square root of 2 plus 5. The value, or in simplified form, square root of 32 is 4 square root of 2 minus 2 times square root of 50 is 5 square root of 2. Let us simplify. 7 times 7 is 49. So we have 49 square root of 2 plus 5 times 4, 20 square root of 2 minus 2 times 5, 10 square root of 2. So if you will try to observe, we have 49 square root of 2, 20 square root of 2, and negative 10 square root of 2. We can consider all these expressions similar, since they have the same indices and radicands. So let us perform the operations from left to right. 49 plus 20 is 69. And then just copy or bring down square root of 2. Minus 10 square root of 2. So we have 69 minus 10 is 59. Bring down square root of 2. So for our final answer, we have 59 square root of 2. Add or subtract the following radicals. Number 1, we have 6 square root of 20 plus 3 square root of 5. First, we will simplify square root of 20. Square root of 20 is the same as square root of 4 times 5. Square root of 4 is 2. Square root of 5 will be left inside, or 5 will be left inside the radical sign. Simplifying this, we have 12 square root of 5 plus 3 square root of 5. So we have 12 plus 3 is 15, and then copy square root of 5. This will be our final answer. Let's now have number 2. Cube root of 4 plus cube root of 32. Cube root of 4 plus cube root of, let us express or think of a factor pair of 32 in which one of its factors is a perfect cube. 32 is equal to 8 times 4. So we have cube root of 4 plus, we know that 8 is a perfect cube, and the cube root of 8 is 2. And then 4 will be left inside the radical sign. So we now have cube root of 4 plus 2 cube root of 4. So these are still similar radicals which can be combined. So we have 1 plus 2 is equal to 3. Remember that the first term has a coefficient 1 here. So 1 plus 2 is 3. Cube root of 4. So this is our final answer. 3 cube root of 4. Next example. 7 square root of 63 plus 3 square root of 7 minus 4 square root of 28. So first, we will simplify the radicands. 63 is the same as 9 times 7. So think of a factor pair of 63 wherein one of them is a perfect square. 9 is a perfect square. Copy or bring down 3 square root of 7 minus 4 square root of 28. 28 still has a factor which is a perfect square. So if we think of a factor pair of 28 wherein one of the factors is a perfect square, that will be 4 times 7. Okay, so we're going to have 7 times the square root of 9 is 3, and then 7 will be left inside the radical sign, plus 3 square root of 7 minus 4 times square root of 4 is 2, and then 7 will be left inside the radical sign. Now we're going to have 7 times 3, 21 square root of 7 plus 3 square root of 7 minus 4 times 2 is 8 square root of 7. These are all similar radicals. So we have first 21 plus 3, that will give us 24. 24 minus 8, we have 16. Square root of 7. So for our final answer, we have 16 square root of 7. We have here a practice exercise. You may pause the video and get a piece of paper and try to answer the given exercise, and then afterwards, you may check your own work. Okay, for the instruction, we have perform the indicated operation and express your answer in simplest form. Number 1, we have 10 square root of x plus 5 square root of x plus 2 square root of x. So the given terms are all similar radicals. So we can add them. 10 plus 5 is 15. Plus 2, 17. And then just copy square root of x. So the sum is 17 square root of x. Number 2, 7 square root of 2 plus 6 square root of 3 minus 5 square root of 2. Let us underline the similar radicals. Only similar radicals can be added or subtracted. 7 square root of 2 minus 5 square root of 2. The difference is 2 square root of 2. And then, just copy or bring down positive 6 square root of 3. This will now be our final answer. We can no longer combine them because they are dissimilar radicals. Let's have now number 3. Square root of 5 plus 6 cube root of 5 plus 8 cube root of 5 minus 5 square root of 5. First pair of similar radicals are square root of 5 and 5 square root of 5. Okay, so the given operation is subtraction. Square root of 5 minus 5 square root of 5, that will give us negative 4 square root of 5. And then we have the other pair of similar radicals, 6 cube root of 5 plus 8 cube root of 5. The sum is positive 14 cube root of 5. This now will be our final answer. Negative 4 square root of 5 plus 14 cube root of 5. Let's now have number 4. 6 square root of 28 plus 5 square root of 7. If you will try to observe, square root of 28 can still be simplified. If we think of a factor pair of 28, wherein one of them is a perfect square, that will be 4 times 7 plus 5 square root of 7. So we have 6 times the square root of 4 is 2. Bring down square root of 7 plus 5 square root of 7. Adding or simplifying, we have 6 times 2, 12 square root of 7 plus 5 square root of 7. Adding the similar radicals, 12 plus 5 is 17. And then copy square root of 7. So we have 17 square root of 7. Let's now have number 5. 12 square root of 90 minus 2 square root of 160. First, let us simplify square root of 90 and square root of 160 using factor 3 method. So for 90, we have 9 times 10, 2 times 5, and 3 times 3. Looking for a pair of prime factors. So we have 3. Write it once. And then 2 and 5 will be left inside the radical sign. 2 times 5. Therefore, 90 in simplest form is 3 square root of 10. For 160, we have 16 times 10, 4 times 4, 2 times 2, 2 times 2. For 10, we have 2 times 5. Look for a pair of prime factors. Write it once. Another pair write it once, and then 2 and 5 will be left inside the radical sign. So 2 times 2 is 4. Square root of 2 times 5, 10. Therefore, in simplified form, square root of 160 is 4 square root of 10. So let us rewrite the given. 12 times the square root of 19 simplified form is 3. Okay, multiply muna natin. 3 times 3 square root of, okay, let me rewrite. Sorry. Let me rewrite it. So 12 times 3 square root of 10 minus 2 times the value of square root of 160 is 4 square root of 10. 12 times 3 is 36. Bring down square root of 10. Minus 2 times 4 is 8. Bring down square root of 10. These are similar radicals, so we can subtract them. 36 minus 8 is 28. And then just copy or bring down square root of 10. Therefore, the difference of 12 square root of 90 minus 2 square root of 160 is 28 square root of 10. I hope you got them all correctly. So that is how we add and or subtract radical expressions. Thank you very much for listening.